we're asked to find this limit. And you can see the limit here isn't a number, it's infinity. What do we do with this infinity? Well, when we put an infinity, we have to work with it because just infinity is infinity, right? But I don't know how to times 10 times infinity. Yeah, it's 1 to infinity, but that doesn't tell me anything. So I want to try to simplify this into stuff that does tell me anything. So what I'm going to do is I'm going to divide everything by the largest exponent in the denominator. So I'm going to do the limit as x approaches infinity, and I'm going to do 10x over x squared plus 100 over x squared. Now, why can I do this? Well, because really what I times by was this, which is 1. So I haven't changed anything, right? But now, as I look at this, I'm going to simplify this down. I've got 10 over x squared plus 100 over x squared. Oh, this is... okay. And then here I have 1 minus 30 over x squared. Now here's the thing. As I put in a really big number into here, into any constant, these always go to 0. So anytime I have infinity in the bottom and a top, they go to 0. So this goes to 0 and this goes to 0. So really what I have here is 0 plus 0, 1 minus 0, as I apply the limit, which is 0 over 1, which is 0. Because I can have 0 in the top, I just couldn't have it the reverse. So then my answer to this is 0. So the limit as x approaches infinity of that function is 0. That's where the asymptote would be on that graph. That's where it'd be headed off to. So hopefully this helps you see this. The big thing is as I said in the notes, you can always put in your calculator if you can't remember. So if I put like 10 over, tons of zeros into my calculator, I'm going to get a really small number, and that's going to help me see that it's going to 0. As this number gets bigger and bigger, get closer and closer to 0. I don't care that I never get there. I only care where I'm going, because that's the definition of limit. So then I can say these all go to 0, giving me this result.